Alrighty, welcome to Advanced Munki Infrastructure, moving to cloud services. If this isn't the session you meant to find, door's right there. I won't be offended, I promise. I'm super excited about this. This is something that I've been talking about with a ton of people, even people in this room, for a while on Slack. So it's kind of fun to finally get up and be able to talk about it. My name is Heil. I am the Senior IT Manager at Myelin Communications. We're a group of advertising agencies in Chicago, Atlanta, and Boston. You can find me at my teenage angsty username on Twitter and Slack, Refreshing Apathy. It just kind of stuck. Picked it when I was about 14. And I am on GitHub at github.com/rickheil. Slides, resources, links, all sorts of stuff is going to be available at my website pretty much as soon as the talk is done. It's rickheil.com/munkipsu 2017. Slides will also be through the conference submission process, so once that goes up, everything will be there as well. I'm going to mention a lot of people's tools and names and little snippets of code and examples, so that'll all be up there afterward if you want to download it and play around. A lot of this stuff is something you can kind of play around with in an afternoon, so sample code is always great. So this morning we're going to cover my prime directive, or why Cloud Munki, and kind of how I managed to discover that as a solution for our company. We'll talk about the power of middleware, which to me is like the least talked about, most awesome feature of Munki. Tales from production. We'll do a little show and tell on how you can use some of these services both with and without middleware. We'll talk a little bit about teamwork in cloud-based Munki. It does change the paradigm a little bit. If you're not using version control yet, this presentation ought to kick you into it. We'll talk about CI very briefly, just a couple of slides on that, because that's an integral part of this. There's going to be another presentation after this in 207 by that guy right there, Mac, and he's going to talk more about GitLab and CI. So we're going to go a little light on that and spend some more time talking about the actual middleware parts. And finally, questions, comments, and tomato throwing at the end. If you have a question, raise your hand and we'll throw a catch box at you and hopefully not spill your coffee. So let's start with the prime directive. Behind every project, every piece of code, every presentation, anything you really want to do, there's always a prime directive. It's some business need, some itch you have to scratch, some want, some problem that made you take action. So for us, the prime directive became pretty simple about 8 months ago. How do we scale our existing Munki deployment to manage Macs in 5 diverse offices over a lot of remote users where we don't have a whole lot of IT presence? As a little bit of background, my company in Boston, Partners & Simons, is owned by Myelin Communications. This is a super, super common advertising agency thing. There will be this one holding company that then owns a ton of different agencies all over the place. Up until about 6 to 8 months ago, while we kind of cooperated on client work, IT didn't really talk ever for much. As the companies started to work together more and collaborate on more clients and promote synergy and all that stuff, we kind of figured out that we needed to have one IT platform. I mean, this was basic stuff like, all right, we've got 60 people using the Creative Suite at this office and 30 at this office. Well, let's buy them together and get a better discount and have more money left over at the end of the year. But also the big stuff, like we have 5 separate email services. We have G Suite, we have on-prem Exchange, we have 365, we have a Carrier Connect server. So we don't have a single global address list. We don't have a single calendar. So you might be on a team in Boston with someone in Chicago, but you couldn't see whether or not they were free or busy to schedule a meeting with them. So it's all of these big efficiencies that we're having to gain. And as we're doing that, we're realizing that the support standards at our different offices are different too. Now we're about 2/3 Mac across all of these agencies, which is sweet because it means I have job security. The first and biggest piece when we're talking about Macs, we already had the support bit really down cold. Our desktop support is amazing. But none of the other offices were doing any real active management. It was all still remote desktop and walking desk to desk and running scripts and installing stuff from a file share or USB drive. So it was not only teaching about these tools that we're using, but also deploying them. These 5 offices plus a couple dozen remote workers really challenged the I have a Mac Mini that's my Munki server sitting in my server room model that we'd kind of survived on until now. Because the Munki server is just a web server, if you Google for that, you'll get 1.5 million responses. The first way I approach this problem is, okay, I have a web service. I need to scale it, and it needs to be distributed. This is a solved problem. let's go for it. There's a ton of different approaches. So we could keep hosting our Munki server on that little 2008 Mac Mini that sits in my server room like 25 feet away from my desk. That's our Boston office. We're in the seaport. What happens when our office gets washed into the ocean? Kind of a problem. So there's also 220 to 230 clients hitting it once an hour. What's that's going to do to our external bandwidth? If we're going to use these site-to-site links we put together on Patch Tuesday for the Office suite or for an Adobe update, that's going to murder our bandwidth between the offices. So that just didn't really seem to be a good solution. So we thought, okay, let's host a Munki server in each office. We'll localize it. Not all the offices have on-site infrastructure. So that kind of went out the window immediately. Okay, what about a cloud server? Well, there's not a whole lot of appetite for an S3 bill. I was talking to some people last night about, a lot of the things we're doing is minimizing, how much expenditure we have on bandwidth. We don't have a multi-million-dollar S3 bill per month for a production product that we can tuck our little, tiny little Munki repo into to hide. So cost was a concern. There's also DR and bandwidth still. And then I found out about middleware. Middleware turned out to be kind of that extra option that I was looking for. Wade Robson submitted the pull request, so he wrote the code for it and documentation. And I saw it mentioned in the Munki Slack channel a lot when they were developing it, but didn't really understand what it was for until I watched his 2016 Mac DevOps YVR talk, which you should watch because it's hilarious. And it's a great little story about how he kind of scratched that itch and found his prime directive. With middleware, the Munki server doesn't just have to be a web server anymore, with apologies to Greg. Middleware opens up a massive amount of extra options for you to leverage new technologies to get your data from a Munki server to the client, even if they're not web servers. Just takes little imagination. So Wade was originally looking for a way to use S3 as his Munki server. He did, same as I did, didn't want to have a Mac Mini or a web server sitting on-prem anymore to do this. Before middleware, you could absolutely put everything on S3 and have your clients pull from the bucket. But your bucket needed to be wide open to the entire internet. Guess how this happened on Wednesday morning? I'll take a wide open S3 bucket to the internet for 500, Alex. You can do that. It's just a really, really bad idea. Because think about all the stuff that's in your Munki repo. You've probably got serial numbers. You've got activation scripts. You might have an errant password or private key in there somewhere by accident. You've got all of these things about your infrastructure. You really don't want to end up on one of these. You don't want to have a name for your S3 bucket except for the URL to it. So security is a problem. This stock image is from Wade. It's beautiful. A wide open S3 bucket might not matter for your collection of cat gifs, but it definitely does matter for your Munki repo. Someone could just kind of tiptoe right in there and make off with all your Adobe activation keys. All right, so let's add some security to S3. To do that, we lock down access and we require an IAM account. If you've worked with AWS, this is their super granular way of letting you assign permissions. You get a pair of keys, a private key and an access key. You use those keys plus the date, plus the region, the method, and you derive a third key that's only valid for a week, and it calculates a signature, and the signature is added to a header, and then you can make your request. So Munki didn't do this. It just wasn't available. You could add extra headers, but they had to be static headers. So that's how you do basic authorization, right? You kind of put in that extra header, but it stays the same. It's not really aware of what URL you're trying to fetch, and that was kind of the problem. That's where middleware comes in. This next slide is code. I know it's early. I'm sorry. This is from MunkiLib. It's fetch.py, if you're following along at home. We are inside the getURL function, which does exactly what it sounds like it might do. In another function further up, which is import middleware, Munki has found a Python script in its base directory, so that's user local Munki by default, that starts with middleware and is written in Python. That script has to have a function called process request options that accepts a dictionary as an argument. So if all those conditions are met, we have some working middleware ready to go. The top piece of this, so lines 220 to 229, is fetch.py putting together a dictionary of options. So you can see some important stuff in there that might sound familiar. So URL is literally the URL it's going to go and try fetch. Follow redirects, you'll recognize that from the Munki preferences. And most of the way down there, we've got that additional headers one. So that's where your basic authorization might have gone, but that's also where all this extra stuff for all these cloud object services need to go. If the middleware is loaded in the second part, all it does is call the middleware function, pass it all those available options it can modify, and then save them back. That's it. On the other side of the equation, this is a function in a middleware file. There's a lot more above this, how this particular sausage gets made, that is beyond my scope and caffeination level right now, so we'll skip that. But this is actually from Wade's S3 auth middleware. S3 endpoint is simply a variable that stores your bucket URL. So it's saying if the bucket URL is in the options, so if the bucket URL is what you're pointing to, add the headers, sign it, and throw it back to Munki. That's it. If that S3 endpoint value isn't present, the headers are just passed back unmodified, same as is. That's actually a really important part, is you don't have to modify the headers. And this function can do anything. Now we're talking about cloud object storage right now, but you can pretty much mangle the request however you want, because all of those things in that options dictionary, you can rewrite. You can blank them out, you can change them 100%. As long as you can do it with a GET request, middleware is your man. So we go from this is an options dictionary without middleware, and if we look at the additional headers piece, which my mouse isn't working, oh well, nope, there it is. Additional headers, it's just the user agent, nothing big. We go to this with middleware. You can see I've added some stuff in bold there, and we get that AMZ content SHA-256, the date, and the signature. Those are not real credentials or signatures. Sorry, hackers. I'm not going to be able to get in. So with middleware, Munki server doesn't just have to be a web server anymore. This is why middleware is so powerful and can really affect the paradigm of what a Munki server can be. By giving the administrator access to dynamically alter the headers, cache control, even the URL, middleware lets you choose your own destiny in a way that hasn't been possible before without heavy modifications to the actual Munki software. That being said, is middleware appropriate for everyone? No. As much as I love this stuff, it's not always the right solution. For some deployments, it's always going to make sense to just have a Linux or Mac server sitting in your server room sending out packages to your LAN. It really just depends. Having the option available to do something different is really important, though. And I'm really grateful to Wade for writing the code and Greg for merging it, because this is a powerful feature that we can use when we need to. This is actually one of those stories I reference when everyone says, oh, well, why do you use open source software in your company? This is a perfect example. Wade had a need, he wrote some code, the community helped him out, and now it's available for everyone to use. I'm aware of 3 middleware scripts that are already available that you can check out right now. 2 from Wade, 1 from Amazon S3, and 1 for Google Cloud Storage. And there's also one by Aaron Birchfield for CloudFront, which works a little bit differently than S3. If you know Python, or if you pay someone who knows Python, the development of these is relatively straightforward. The hard work has already been done in the middleware script that's included in Munki. Really all you need to do is implement the authorization parts, so that's all that signing stuff. In his DevOps YVR talk, Wade basically said he just looked up the Amazon docs for Python and how to do it, and followed them exactly, and had it working in a day or 2. So let's do some tales from production. How can I actually use this? And I have some pretty diagrams here. So as a system, this is kind of what a normal Munki server would look like, right? You've got your client on the left, it does a GET request to your server, maybe it authenticates using basic authorization or a certificate, hopefully it's using HTTPS. Server says, yep, I've got that file, sends it back from the disk. This has been going on for how many years now? Really, really simple. So let's talk about a couple of ways, 3 in fact, that we can leverage some cloud technologies into this, both with and without our newly acquired love for middleware. First one is Squirrel. It is an open source, purpose-built Munki server written in Go by the guy in the purple shirt at the back of the room right there, Victor. He is at Groob. Thank you. Squirrel is probably the easiest way to dip your toe into the cloud storage piece of this. Because it allows you to store your files on a local disk, on Amazon S3, or on Google Cloud Storage, you don't actually need middleware to take advantage of the distributed nature of your storage system. there's nothing special to do on your client other than set up basic authorization, which hopefully you're using something like that already. Point the URL, add the auth, and that's it. So system-wise, it's not that much different. We have our Mac endpoint, sends a GET request over HTTPS, which Squirrel does automatically using Let's Encrypt. Has basic auth. Squirrel then signs all the requests and does all the kind of the meat and potatoes stuff to be able to get your file either from the local repo or from those cloud storage bits, sends it on back, and then your server gets the file. So it's a little bit of added complication, but there's nothing to do on your clients, which is kind of nice. There is also a Docker container for this if you want to host it that way. If you're using cloud storage, it's a perfect model for Docker because there's no real persistent stuff except for the certificate. Some pro-con stuff, and we'll do this for all three of the options that I'm kind of presenting today. It is incredibly easy to set up. I had it set up and running in about 5 minutes. You can use Docker, but you can also just download the binary and run it from the command line. Super, super, super simple. You only need one cloud account, so you just have to have one account that can read your files, and that's it. There's no more complication than that. Another big pro is that the keys to your cloud account never hit your client. This is one of those things that's kind of a little bit of a security question. It's a little open right now. If you, for instance, put basic authorization, the client who really knows what they're doing is going to be able to figure out what username and password you're sending to the server. That's still going to happen with Squirrel. It's going to happen with anything you're sending basic auth to with Munki, but your repo keys aren't there. And finally, basic auth and HTTPS means you have pretty decent security startup right out of the box with almost no effort. On the cons side, the only one that I could come up with is that each request fetches the file. Now again, I'm coming from the aspect of my current Munki server is free, right? I'm just using power and bandwidth I already had available. I would like to keep this as close to free as possible. Depending on your deployment size, this may or may not matter. If you have a big production department who has an S3 bill that's more than all of our salaries combined, then you're probably going to be able to get away with some download fees and bandwidth fees here and there. The only other thing that you have to watch out for is that if you have a large update, so Microsoft Office or maybe some Adobe apps, you don't want to melt your internet connection having all those clients check in at once because Squirrel is going to fetch that for every client. So keep in mind that you need to size your network connections appropriately for this. So thank you, Victor. You're awesome. For the second example, let's talk about how you could use S3 directly. So instead of having Squirrel do the middleman work, you can just go right to S3 if you want. This will use middleware. This is what Wade's S3 auth middleware does right out of the box. And while we're going to talk about Amazon, all the principles for CloudFront and Google Cloud Storage, and really any cloud object storage that you want to use are pretty much the same. So for setup on the S3 side, you need to create your bucket. You need to disable all of the public access ACLs so that not anyone can just waltz into your repo. The one confusing thing that I call out anytime I talk about S3 ACLs, there's this option that says allow any authenticated AWS user. And at first you think, oh, that's awesome. Everyone on my account can read this. It's any AWS user anywhere. So anyone with a valid key could read it. So don't check that box. It's not the one you're looking for. So create your read-only IAM user and create the read-write user for yourself. So your read-only user or users are what you're going to give the keys to your clients, right? And then yourself, well, I mean, you need to get stuff up to the repo, so you need some write access. Wade has a very detailed walkthrough, including a copy-paste of the policies that you can put in to make these read-write users. It's on his S3 Auth GitHub, and the links are on my site in that resources bit. So for S3 Auth, the actual installation is super simple. Make a package and just drop the middleware Python script to whatever your Munki root is, so user local Munki in this case, so just making middleware underscore s3.py. And then create a configuration profile with your middleware settings. So that's your access and private key, that's what that S3 endpoint might be. And each script has a little bit of a different setup, but I have an example configuration profile on that resources site for Wade's S3 middleware. Again, this does get into the security realm of things, which is how much do you trust your users to have those keys semi-visible. So if you're not disabling the profiles preference pane, have a thought with that. All of these middlewares can be modified because they do run as root, because Munki runs as root. The common thing that I've been talking about and seeing is put all the secret stuff in the root user's home directory, make it read-only. It's a good way to kind of tuck things away. A really motivated user is always going to find it, but that'll keep it kind of out of view for most people. And of course, you can install both of these with Munki. So how does this look compared to Squirrel? I've kind of broken the middleware out a little bit for this one, but essentially it's exactly what we talked about when we went over that code. It's Munki is running, passing the options dictionary to middleware assigns the request, and then Munki simply fires that request off to S3 and retrieves the file. So what are the pros? You don't need a server anymore. You don't need anything for a local infrastructure. So that Mac Mini you've been having sitting there, it's probably just for AutoPkg now, or maybe not even if you automate it with GitLab. It's super straightforward to set up and troubleshoot, because this is probably the least moving parts way to do it. You have your Amazon accounts and you have an S3 bucket. The S3 bucket, unless Amazon breaks half the internet again, is probably going to stay up pretty well. So really you're just looking at the account bit of it. Amazon buckets do come with an HTTPS cert by default on that name. So again, not something you have to spend money or time configuring. And S3 is pretty reachable most of the time. Cons, like I was mentioning, the keys for that IAM account are on the client. It's one of the reasons we're deploying it with a profile, is because we rotate those keys out on a schedule. So that way, if someone does have the keys, or if we have an employee who departs, we can rotate those keys out super easily. Another con, you're still paying for each file retrieval and the bandwidth that you're incurring by downloading it. Every client's just going to reach out right to S3 and grab it. So again, you want to make sure you're not melting your outbound connection. Make sure you have the bandwidth. Now we come to the third one. We've kind of gone in order. This is the most complex, but also probably the most powerful in some ways. And this is what we're currently using in production across all of our agencies. It uses a combo of the S3 middleware as well as Nginx to do reverse caching. So HTTPS is available on both the local proxies and when the clients are going direct to S3. It allows us ultra-granular cache control over everything that our Munki clients would be fetching. And it allows for super fast LAN downloads. So people ask, why would you go through the hassle of having all these little local caches in each office? Just pay the S3 bill and be done with it. That's why. It's probably kind of blurry, but that's a 500 megabit scale on the bottom there. The blue is outbound bandwidth to our LAN. This is on a day that Adobe did some updates that we pushed out. Yeah, so that for one of our offices, it does about 1.75 terabytes of traffic a month. That's a lot to save from going out to the rest of the internet. So this is a good summary of why. The green is it fetching the packages as it's first being requested, and then every single other request after that first download's finished is going to be served from cache instead of from S3. Why local proxies? Significant bandwidth savings, both on outbound bandwidth for yourself and on paying Amazon or Google or whoever your cloud object storage provider is, which translates to cost savings. As I mentioned, we're trying to do this as close to free as possible. And you get the wire speed delivery of updates to clients on your LAN. So whether that's wireless or wired, you're going to get a decent local configuration. It also allows us to aggressively cache resources that don't change. So things like icons and really even the package files themselves. Because if the package file changes, it better have a new version number, right? That way, when someone downloads the entire Microsoft Office suite or a bunch of Adobe apps, or Xcode, Xcode's another popular one, you get that wire speed delivery, there's no hit to S3, and it's super fast. So what's in a proxy? Almost nothing is the answer. We use super small virtual machines. I run Ubuntu Linux. You can run pretty much any operating system you can compile Nginx on. We use one CPU core and a gig or two of RAM, depending on the office. So for 100 clients, I'm using 2 gigs of RAM. For less than that, I'm using 1. Nginx is pretty efficient, doesn't need a whole lot of resources. They're hosted locally in each office. All of our offices have at least some small virtualization infrastructure there that we were able to latch onto. So there's no additional licensing or hardware purchases that we need to make for this. We're using the NGX AWS auth module. So when clients are on the LAN, and we'll get to this in a second, they're not actually using middleware. Nginx is doing all of the signing for them. The reason we have to do that is because otherwise Nginx is going to try and cache based on that authorization header, which is going to be different depending on the date that each client was configured. So it wouldn't actually efficiently cache things. That signing key does expire once a week, so we're using Chef to set up and configure everything. And I just have a scheduled job that regenerates that key on the first day of the week. And you need enough disk space to hold your Munki repo once plus a little bit more. The idea being that depending on how you set up your caching, pretty much the most it's going to get is about 1 to 1.25 times what your storage is. If every single package is downloaded and then you've added some new packages and they get downloaded before some of the old ones expire, it's about the max storage you're looking for. So depending on the size of your Munki repo, I know ours is ridiculously large. Thanks, Adobe. So this one looks a little different than everything else, and I'll explain. The secret sauce for us is DNS, because it's always DNS. We already run split DNS at all of our offices. So internally on the LAN, clients resolve the repo, so munki.example.com, as that local proxy that's hopefully sitting somewhere not too physically far or network-wise far from them, which is set up to cache everything. Externally, munki.example.com is a 301 redirect to the S3 bucket. So what the middleware is doing is actually following the URL that that options dictionary is passing to it, figuring out if it has a redirect. If it does, it signs it because it's no, I'm going to an S3 bucket because I followed that redirect. If it doesn't, it presents a basic authorization, which is what we have our local proxy secured with, and it fetches it from the local proxy. So why is this useful? We have a lot of people who wander between offices in 3 different cities. We have a lot of people who work from home and have iffy home bandwidth connections. We have a lot of people who work from home and aren't on a VPN because they're doing sales or they're doing lead generation. So they're not hitting maybe an internal file server that might require them to be on a VPN. So this lets us not force them to connect for software updates. They can just go right to S3 and it's still just as secure. This lets us have a lot of flexibility on what else we cache as well, which we'll hit in a minute. So you're probably asking why the trouble. Again, fast updates saves you bandwidth, saves you money, and it's tunable. The cons, it's more moving pieces, right? The more pieces there are in a system, the more likely it is that you're going to have some problems. It does require DNS changes, which is always fun. And complexity, good and bad, good and bad. Money-wise, when we ran straight to S3, our bill was a little over $400 a month between bandwidth and requests and storage. That was for one office of 80 people. I am now paying less than $24 a month for 225 clients. So basically beer money for my Munki repo, which is sweet. Some other fun proxy tricks that you might enjoy. Due to historical reasons, our old Munki URL had some extra stuff in the path. We can rewrite that using our proxies and kind of force them onto the correct URL, and we can detect that. We can efficiently serve any specific static content we want. So for instance, we have some software titles that have pictures in the description. We can serve that through the proxies now. So we have kind of our own local CDN, and we can make that cache pretty much infinitely if we want to. We can set up alerts through our log shipping system. If a client checks in and requests the site default manifest, we know something's gone terribly wrong, because by the time that the client is reaching out with Munki, it should have already been bootstrapped and have its manifest set up. So we can set up an alert through Graylog with that, which is super handy. If someone takes their laptop to the Genius bar without telling us and has it wiped, and then they come back, and usually we get about a 25-minute heads up that their laptop needs to be reconfigured before they call us and say, why don't I have Microsoft Word anymore? And lastly, the stub status module, it makes pretty graphs, just gives you information on what Nginx is doing, how many cache hits it's served. I love pretty graphs. It's basically my reason for existence. All right, so back to the prime directive. We covered the last mile, right? So we're covering the technology part. That's the easy part because computers do what we tell them. How do we manage Macs in 5 diverse offices? Because it's not just me. It's myself, it's Matt, who is here this week, and it's Nick, our guy in Chicago. And all three of us need to be able to make changes to this entire system. If you attended Nick McSpadden's talk yesterday, then you know that I'm about to say Git is the best. We use plain old Git to track our icons and package files in our Munki repo. And we're using Git LFS, which is large file storage, to track packages, DMGs, whatever else. LFS is an open source extension to Git that is developed primarily by GitHub. It uses a special HTTP API to convert Git refs into large files only when you need them. So you're not storing historical files on your local copy, which is really advantageous. Our repo's big, again, thank you Adobe, so it's nice to be able to not download everything all the time. So it helps you control your local repo size a little bit. The good things, every change, so every commit, is tied to a specific person. So we now have an auditable log of exactly what's going on with everything in our repo. It follows the infrastructure as code push we're making. I know that's been a big topic of discussion for a long time in the MacAdmins community. And this is kind of pushing us further to be able to define everything with trackable code. And it provides a centralized repository, but allows us to work independently. Now there's always something bad about Git, because it's Git. LFS doesn't have object expiration yet. So that means that your create OS 10 install package from 10.10 is still hanging out on your server when you're using Git LFS 2 years later. It is on their roadmap, and you can delete things manually if you're running your own Git server, which we'll get to in a sec. But if you're using something like GitHub, you're going to run into space problems pretty quickly. Your team members need to have at least a basic understanding of Git as well, and that's no small feat. It can be a little complicated to learn. And then you have your branching strategy wars. Everyone likes to have their own way of setting up their Git repo, so agree on one before you start. So some tips on getting started. Agree on a branching strategy, really. It's pretty important to define exactly how you're going to operate within this repo, especially if you're going to be using automation. Put your catalog files in Git ignore. Don't track your catalog files in Git. It is noise. It will just make it a pain in the rear end, because every single time you change one tiny little thing in your repo, you're going to be adding 1 to 3 more files. It's really just not worth it. Generate them when you deploy, because that's really the only time it matters, quote unquote. Use Git LFS to track the big stuff. Regular Git with a file over about 15 megs is not only an inefficient system, it's really bad at hashing them. Whatever algorithm they're using is ultra, ultra, ultra slow. So it's going to take forever for Git to diff things and figure out, has this package file updated? Git LFS is written in Go, and it's super fast at that. We started out in our repo as about 45 gigs, and it took longer to copy and paste the git clone URL than to actually figure out what a list of stuff it needed to download. Git LFS prune is a local command you can run. Essentially, that deletes any packages that Git LFS has downloaded for you that aren't in your current working copy. So that way, if you're done with a package and that's been taken out of your branch, you can run Git LFS prune and delete a bunch of stuff for you. Seriously, branching strategies, have one. We use Git flow, which is a pretty standard one. We're using feature branches for new software and software updates, hotfixes for stuff that needs to be done right now. So, new client comes on, we need to get a manifest in the repo for them. And we're using support branches for when we mess up. So no support branches is a good day. And I'll have the Git one-liner that makes this pretty graph for you on my site too, because I like this one. So we use GitLab as our Git server. GitLab is self-hosted. It has a community edition that's free and comes with a lot of goodies. It also has a enterprise edition which comes with all sorts of extra stuff. So if you're doing more software development and you need kind of lifecycle controls, issue queues, Kanban boards, all that stuff, it'll do that. It's just not something that we use. We're basically just using it for Git. It comes with Git LFS right out of the box. You just check a box and it's done. It runs on Ubuntu. They have a package now that sets everything up for you. This used to be ludicrously complicated to set up, and they've really done a lot of work to make sure that it's easy now. It's just installing one package from their repo. And it also has continuous integration, CI, built in, which is what we're going to talk about next. If you are interested in GitLab, Mac, who's sitting in the 4th row there, he's doing a presentation next in 207 that talks about a lot more of the automation features you can get out of CI and what GitLab does. So what is CI? Stands for continuous integration. The way GitLab CI is set up is it uses something called a runner to accomplish tasks. So runners are just software that's installed on a machine of pretty much any OS that just sits there and waits for a job. Those jobs are assembled into something called a pipeline. So you can define multiple jobs to run in a specific order or parallel to each other. So you can build software, run tests, run any arbitrary task you want. On the shell, it's going to use Bash or whatever your standard shell is for Linux, Mac OS, pretty much any Unix-like operating system. You'll use Command Shell on Windows. If you have Windows infrastructure, it will work. And you can also use Docker containers, which I think is probably the most powerful part of it. So why use CI with Munki? Because I never have to synchronize anything to my Munki repo. CI does it for me. It provides kind of the one golden path to production. Anything that's on master branch is what's on production. So you kind of get like a continuous deployment effect out of it. There's no extra steps. For us, we simply use a merge request, and if the policy is you can't approve your own merge request. So there's always one set of eyes before it hits production. As soon as we hit merge, CI runs, builds, pushes it out for us. You get repeatable build environments, and this is more key in other software development, but also helpful when you're talking about things like Munki. Using Docker containers gives you a fresh, configured start every single time you're going to run these scripts. So you don't have to worry about someone else running a script somewhere that's going to mess up your environment and cause all sorts of weird errors that all you have to do is restart. You get logs of everything. So everything that CI does is stored in a log file you can view and download later. Again, great for troubleshooting. And you can run things on schedules, which we are using a lot. We'll talk about that in a second. There are a few things you want to watch out for with CI. One is that it will do exactly what you tell it to do, which is good and bad. CI is just another computer, so you do need to be careful with how you write your scripts. It can be slow to work with really large repos, really slow. Our CI process is about 19 minutes from start to finish to deploy the Munki repo. And about 17 of that is cloning everything into the Docker image. There are some ways you can kind of get around that, and with a smaller repo, you'd probably be looking at like 7 or 8 minutes, but ours is preposterously large. It is another moving part, so it's one more thing to learn about and troubleshoot. That may be good or bad, depending on your attitude towards those things. And you will be tempted to script literally everything through CI. We started with CI for just getting things from Git to Munki, and we have now added pretty much any routine, automated, repeatable task to CI at this point. We're going to talk about a couple of them. We'll go over how we're using our Munki CI, and then I'll show you real briefly how I'm actually running AutoPkg with CI. So this is the entire CI file for our Munki GitLab project. It uses a Docker container running Linux, which will be openly available as soon as I finish automating its build with CI. Essentially, it's just doing one quick build stage. It's cloning the repo, so that's that Git strategy thing there. It's running a lint file, so that linter goes through and checks for a bunch of things. I'll talk about that in a sec. It's running make catalogs. Make catalogs is just Python, and it will fall back to using the plist library. So you can actually run it on any system that supports Python. You don't have to run make catalogs on a Mac. So this means we don't need to have a Mac to build and sync our Munki repo, which is sweet. And then it's just syncing catalogs, icons, manifests, and packages to S3, deleting anything on S3 that's no longer in the Git repo. So if we're deprecating a package and moving it out, it'll remove it off of S3, save us a couple pennies a month. It's only running for the master branch because we only ever want the master branch to ever hit production, right? And then the artifacts is kind of cool. Essentially, it's going to save out the catalogs. That's really the only dynamic thing that we're generating here. But if we ever have any problems with make catalogs, we can actually download those generated catalogs and take a look and hopefully figure out where they went wrong. One thing that's really important, if you look on the AWS lines, you'll see a $AWS_bucket there. GitLab supports environmental variables that will pass from GitLab into whatever runner you have. This means you can keep secrets completely out of the repo. So none of our AWS keys, none of our deploy keys, none of our usernames and passwords, nothing is in Git. It's all stored and hashed by GitLab, and then it's just passed in as soon as the CI runs. So that's another way to make sure that your runners are basically disposable. As soon as they're gone and that Docker container is deleted, so are your secrets. So it's nice to have that added little layer of security there. And that way, if you accidentally push your Munki repo to somewhere else that's public, you don't have to reset all your keys. I talked a little bit about munkilinter. This is mostly copy and pasted the hard parts, which is listing all the package files and stuff from make catalogs. Again, I love open source software because I can steal from everyone else. Makes my life easier. We had some problems when we were trying to use Jenkins CI before we started using GitLab that made us want to lint everything. And the big thing was that Jenkins wasn't cloning the LFS files correctly, so we'd get pretty much every package great, and there'd be one or two that would be corrupted. And then we get a ton of warnings spamming in our Munki report dashboard saying that a file hash didn't match. So all I did is write a quick lint file, and first all it did was just compare the file hash that was about to be synced to S3 to the file hash in the package info. If it didn't match, it stops CI and throws up a big alarm bell. I actually have a Hue light on my desk. I made it flash red. I'm a nerd like that. Eventually, we're kind of using it for enforcement of good things and bad things. So good things, it runs a plist syntax check on all the package infos and all the manifests. So again, if any of those are bad, it's going to kick out and make sure that we know to fix them. So bad information shouldn't go to production. But it also is kind of like the pretty things enforcer. It makes sure everything has an icon. Everything has to have a description. You have to fill in the notes field with a little bit, at least, imported from AutoPkg. If not, this package is for XYZ, contact this person for licensing, et cetera, et cetera. Make sure that the category is set correctly. We enforce a specific number of categories. You can really make it do anything. Again, it's just Python. This will be available on my site later today for you to hack on and laugh at how anal retentive I am about my Munki repo. AutoPkg is the other big thing that we use CI for. So this is the CI for our AutoPkg runner. You can see the tags specify it needs to run on a Mac, which it does. This is actually my old Munki repo host that runs this. In this case, that Mac is specially set up. It has the Munki repo clone to it. It has a user that can push and pull and add commits to it. It has AutoPkg installed and has the recipe repos already available. So when the CI schedule is called, it simply calls this job and doesn't set any variables. So this tiny little bit of bash sees that it's not passed a recipe name and instead calls a big long bash script, which is hacky and terrible and therefore perfect for production. And all this does is go through and look at all the overrides that are stored in our Git repo for overrides and call a new instance of CI with that recipe name. I should probably remove those instead of saying, if the name is this, don't run it, but it's on the list. I'll get there eventually. Again, you can see there's a ton of environmental variables being passed through. Really try and leverage that wherever you can. And you're probably asking, wow, that's awesome. How do you actually get AutoPkg to run, and how is it Git aware? And the answer is Facebook. No, really, Facebook. AutoPkgTools.py was released by the Facebook CPE team on GitHub, so it is open source. And it's a full-on wrapper that supports both AutoPkg and Git. So I'll scroll back to that first one. So you can see that I've added Trello integration because we use Trello cards for everything as kind of task tracking. Out of the box, it has a function for you to just kind of drop in whatever notifications. You can make it send an email, hit an API call, Trello, kind of whatever you want. Essentially, you run AutoPkgTools.py, you pass it the recipe name, and what it'll do is it'll run AutoPkg for you. So if there's something downloaded but not imported, it will delete that, clean up after itself, and it's like nothing ever happened. If there's something downloaded that does need to be imported, it will create a Git branch for it. It will add the package using Git and LFS. It will make a commit for it, and it will push the commit back to your repo. And then it'll run whatever task you tell it to, so in our case, that Trello card. If it runs into errors, it will bail out, clean up after itself, and then also make another curl call using that task to do, again, whatever you tell it to. So for us, we hacked in some of the GitLab environmental variables to that. So if there's any AutoPkg errors, it will simply pop up a little Trello card and say, there's some kind of problem, here's a link to the logs, click it, and you've got a full download of all the logs from that AutoPkg run. The reason we kind of do this weird recursive thing is that you can, by running only one software title per CI run, you don't have to scroll through like 10 megs worth of text logs, like really verbose AutoPkg logs, to find something if something goes wrong. We have a really repeatable, iterable granular size to work with. GitLab also allows you to rerun a pipeline. So if, say there's a really important package we want to grab and AutoPkg times out and errors and doesn't actually download it, instead of having to wait for the next scheduled run, we can click on that link that sends us to it and just hit the retry pipeline button, and it'll redo it for us really quickly without having to hit every single recipe in a row. If you've got a ton of AutoPkg recipes, it can take a while. There are a couple edits I made to the GitLab script. Basically, it was just setting it up for Git flow. They just used a straight up branching name, so it would be, instead of just being the branch name called Google Chrome 55.10 other numbers, it's now feature/Google Chrome. And you can set that up for whatever branching strategy you like, whatever happens to be your favorite. We added our branching model, added some GitLab stuff. It took me an afternoon, and I was running on GitLab. Really straightforward. This script is amazing. I was talking to Nick last night. He uses it among a lot of different teams, and you can kind of call this manually too. So if you are looking to mess around with it, you don't need to set up all the CI parts. You can just grab this wrapper script, stick it on your machine with AutoPkg, and kind of mess with the results from that, and then kind of automate it when you're ready to do so. Only thing I have to say is that they use 2 spaces in Python instead of 4 because they're a Ruby shop. So it makes diffing against their stuff a little bit difficult. A couple of CI tips. As I was saying, use GitLab's variables function. Keep your secrets out of the repo. It's been mentioned at a couple of the talks I've been to. The last thing you want is a private key ending up on GitHub by accident somewhere. It's not a good look. Use proper error handling. Don't just put exit 0 into all your scripts. That's not the point of error handling. The way that GitLab CI is set up is that if any of those steps return an error code, so a non-zero exit code, it's going to kick out and stop. So you can kind of control this. For example, our munkilinter, we can throw warnings but still exit safely and say it was fine for things we really don't care about, like if the developer name isn't set. That's not something I'm going to halt a release for, but it is something I want to know about so I can fix it in the next release. Only hard enforce the standards you care deeply about. So if you really don't care about authors and categories, don't make CI stop on them. You're just going to annoy yourself and everyone you're working with really quick. And the final one is protect production. GitLab has some branch protection that will make it so you can't accidentally push to production, especially if you're not really, really comfortable with Git and branching. There's nothing worse than realizing that you've just put your work in progress stuff onto prod by accident. So put a little protection in there to make sure. Again, we use merge requests, so it's kind of hard to make a push, go to GitLab, click the create merge request button, accidentally click 2 more times to merge the merge request, and go, oh crap, I just deployed to production. It's a lot easier. So again, go to Mac session in 207 if you want more GitLab. We'll let him cover the rest. There's a lot more stuff that GitLab and CI can do. Again, because you can run pretty much anything on Docker, it can really do anything that you want to automate. But what if I don't want to use CI for Munki? Well, you don't have to. Centrify has contributed file repo plugins to Munki. That was merged a couple months ago, I think. And Clayton, who's sitting right next to Mac, contributed the one that I've been testing, which is the S3 repo plugin. Thank you. The basic gist of this is instead of having to work on your working copy, say, on your Mac, and then use something else like Amazon's command line tools or CyberDuck or whatever transfer program you like to push your changes up, the Munki tools are natively going to understand whatever file storage you're using. So the most basic file repo plugin is the one that does exactly what Munki's been doing forever, which is just the local disk. So when you use Munki import, it's looking and saying, okay, I'm just going to save this to a local disk. I know how to do that. With this plugin, that allows you to shim in support for anything. So for instance, with a read-write AWS account and some setup, which is well documented on Clayton's repo, you can have things like Munki import your package and package info directly to S3. So you don't need this whole extra stuff. So if you're one person and you really want to use this but don't want the overhead of Git and GitLab and all this stuff, you can absolutely use these file repo plugins today to get stuff to and from production super, super easily. Obviously, you still want to have a way to edit production by hand if you have to, so some kind of console client to do that is helpful. But I can see folks who don't need the super fancy Nginx caching capability and they don't need the complication of GitLab, spin up a Squirrel server on literally anything you have sitting around, use the S3 repo plugin, and boom, you've got Cloud Munki. Done. So what does this get us? This gets us an automated Munki environment, essentially. This gets us a place with CI where you can do pretty much any routine administration task and have it be repeatable and logged without you touching anything. It gets us super fast downloads to the client. They're cached locally. In the case of some of these, it gets us one less server to take care of on-prem. From the managed service provider perspective, this is, to me, a game changer. To be able to throw a client into the cloud and have them have access to it and not have to, pay for some server in a colo section or add a ton of monthly bill or overhead for me for doing updates. This is huge. It gets us a single place to update our master copy of the repo for as many offices as you want to push it out to. It gets granular error reporting, it gets automated builds, it gets AutoPkg without having to have a Mac sitting around and running it locally. The sky's really the limit. If you can automate it, you can do it. So one of the things I'm looking at is tying our inventory tool and a DEP scraper into CI. So that way when we order a new machine, it'll automatically create a new manifest for it based on the serial number. Maybe the next thing I would do is tie into our HR information system and understand, well, all right, we've got a name in our inventory, we've got a name in our HRIS. HRIS knows what department the person is in. Cool, let's preload a manifest without touching anything with using CI and some scripting to preload all their apps, so that way I can hand a person a shrink-wrapped computer. The possibilities are really endless here. By putting in place the structure for this automation, the structure for not just having Munki be a web server anymore, we're kind of setting up a foundation. It's easier to scale when you're starting from something that is infinitely flexible. And I'd like to think I've followed the prime directive a little bit. So that's all I've got for my talk. We've got some time for questions, comments, tales from production, any tools if you've kind of messed with this that you've found interesting. Oh, we got a catch box.
I work for an MSP, so I've kind of hacked up a poor man's solution of what you did here. One question is, how do you handle like reposado, or do you handle that at all?
So right now we're not handling reposado. That's actually Matt, the guy in the red beanie who was on my slide. That's his job right now, and he's not done with it yet. So I'll be able to tell you that in about 2 weeks when the project when the project is due. There is someone yesterday, and I can't remember who, was talking about a tool that they had written to automate reposado updates with CI. I can't remember for the life of me who. Oh, it was Wes. Okay, thanks. He works at Square. So I would keep your eyes out for that and see what that tool looks like. Again, you could use something similar at this. At the end of the day, that's also just looking for, a web server, quote unquote. So maybe you use these caching proxies to kind of translate that from a wide open S3 bucket into something more usable. Again, it depends on kind of what that environment looks like. But if you can think about it, there's probably a way to do it. So I would look for what Wes has, and we'll see what he comes up with, right? Any other questions, comments? Oh, up here in the front row.
Just a quick question. You said that it was $24 a month for how many clients?
About 225.
225. Okay, thanks.
Yeah. So really, because remember, you're really, say you're updating 10 gigs of packages to 225 clients. Theoretically, it's only being downloaded as many times as you have proxies, right? So you have 5 proxies, so we should only see 50 gigs of traffic. Plus, there's a little overhead for folks who are working from home or remote workers, teleworkers who are just grabbing it directly from S3. But we're talking fractions of a penny per gig, so it's very slow to add up. What percentage is data bandwidth? I don't know, but after my screen is no longer mirrored for the world to see, we'll look it up on my AWS because that's a good question.
So this is an awesome presentation. Thank you very much.
Thank you.
We are starting to dip our toe into this water. Again, another MSP style solution. We opted to try CloudFront out, and simply because the distribution cost is going to be less than it is over S3. Can you do the same kind of caching situation that you're doing with the S3 bucket as a whole with a CloudFront environment?
Yeah.
Okay.
Absolutely, yeah. And so the only special sauce with Nginx itself is that Nginx AWS auth. That's doing all the signing for clients who are on the LAN. That way they don't have to use their middleware.
But they have to use their middleware when they're out
When
in the
they're
field.
off, right. So we're using both, basically.
Right.
So you could do the same thing where you have a CloudFront middleware that people are using when they're in the field.
Right.
And Nginx will do reverse proxy cache for literally anything, any
What,
HTTP content.
what determines whether or not that middleware is in use?
DNS.
Okay.
So as I said, we're running split DNS.
Right.
And the one out in the field is actually just a redirect, an HTTP redirect to the bucket. So our middleware simply reaches out with the requests library in Python and sees if there's a redirect, and if it does, pulls down that modified URL, so that redirected URL, and then signs that. So that's where we do the kind of, is this an S3 or not?
Got it.
That also prevents signing requests. Say someone's at at the airport and Munki's firing off trying to download things, and they get like a splash screen redirect.
Right.
That prevents us from signing a splash screen request, basically.
Got it. I don't suppose those parts of your environment may be made public.
Probably.
Okay.
It is on my list. I do have a little more cleanup to do.
Sure.
My Python is somewhere between passable and decent.
Well, that makes it twice as good as mine. So
There are a lot of people here who know Python a lot better, so I'll probably run it through them to make sure I'm not doing something real stupid first. But yeah, I mean, that's the beauty of the middleware script, is that probably with an afternoon of Googling, you could modify, because I just modified Wade's script. I mean, it's pretty much, all the signing stuff is all his. All I did was just kind of insert a little bit more logic for my particular application. And that's something you can do with just an afternoon of Googling. Say, all right, well, Python, how do I figure out if there's a redirect in my URL? And done. Yeah,
Right.
absolutely.
okay. Thank you.
Anyone else want to be a target of Tom's throws?
I'm pretty accurate.
No? All right, cool. We've got some more time for coffee then. Thanks, everyone, for coming today, and travel safe home.